Okay, so the key information so far is that sine is the y value and cosine is the x value in the unit circle. And we looked at how um, the sine and cosine of 30 degrees can be derived, you can get the result on the unit circle using the 30, 60, 90 triangle. And so here we see, I'll just write it up again, that the sine of 30 degrees is the y value, it's 1/2 because we have that labeled. And then the cosine of 30 degrees is the x value, which is root 3 over 2. We also looked at the 4 corner points for sine. Let's do the same thing for cosine. So for instance, what's the cosine of 0 degrees? Well, cosine is the x value, not the y value. So if you come over to 0 degrees, see, theta is an angle that's sweeping out, but you actually start here, okay? So when you're starting right here, well, the x value here is 1. So the cosine of 0 is actually 1, which is really interesting. Okay, so what about the cosine of 90 degrees? Well, you go up to the top, x is 0, okay? You see how this works? So you tell me what's the cosine of 180 degrees? Well, we're down here, and it's the x value, so it's -1. By the way, I think this is actually the best takeaway from the unit circle. Because if you know your kind of 30, 60, 90 triangles, you can figure out things like the sine and cosine of 30. But you actually can't with cosine and sine. You'll see other ways to later for these, like, I call them the corners, okay? Because they don't fit into triangles. Finally, if we do cosine of 270 degrees, that's down here. X has a 0 there. All right. So what else does one do with the unit circle? Well, there's something else, okay? And it has to do with all the angles in between. And you can even keep going. In fact, why don't we keep going just a little bit more? One more here. What's the cosine of 360 degrees? You actually look, 360 degrees. You go all the way back to where you started. So you're at that point, okay? Cosine is just the x value, so you're there. X value is 1 there, it's 1. You made a full rotation, you're back. And what the heck, I can't resist. Let me do one more. I'll give you a little challenge here. What's the cosine of 390 degrees? Now, if you've never done one like this, you might be stuck. But what do you think it is? If you're following what I'm saying, okay, cosine is the x values on the unit circle. So I start at 0. I'm getting all these different x values for each angle. I go all the way around. I come back to where I started, but I keep going 30 degrees more. Okay? That'll get me to 390 degrees. So I'm back here at this point. I know what the x value is at that point. It's root 3 over 2. And so this is a major topic. I should say theme. Area of study. It's called periodicity. We're rotating through and we're repeating. Okay? And basically we end up with something amazing, which is like waves in nature. Okay. So that's another topic really, but I want to focus on some other angles here. Let's try the following. What if I say theta is 150 degrees? How do we do that? Well, we got to make it like an arc somewhere, so let's make it in here. And I go out to say 150 degrees, right? So what that means is I'm 30 shy of 180. So if I want to try to draw it from here, maybe I'm here. Okay, now I want to know, what are the coordinates of that point? Well, do you have an idea of something we could do that was similar to what we did before? So again, this is 150 degrees. Put it inside here. But then what's left over is 30 degrees, okay? So now that's interesting because what we want, keep in mind what we want the coordinates of that point, okay? We don't know what they are right now. But do you see how you can use the right triangle to get them? Look at it. It's like, hey, that's 30 degrees, like on this side, we can make the right triangle. Should be the same height, but it's a little off. Hard to draw everything to scale here. And we know our 30, 60, 90 triangle, right? We just did one here. We can do the same thing here, right? Because r has to be 1. That's the big key with the unit circle. And that's why this works, okay? Don't think that sine is y and cosine is x always. That's only for unit circle, okay? So I should make a note there for unit circle. For unit circle. Okay. Okay, well look, it's the same triangle, right? This is root 3 over 2. And this is 1/2. That's the triangle. But what about the coordinates, right? The coordinates are a little different, right? Like, for instance, if I go down here, the radius is 1. Okay, the radius is the distance. But the coordinate for y is actually -1. So over here, in this quadrant, you have to take the signage into account separately. And so when you look at root 3 over 2, that's on the left side, right? So this is a standard coordinate system. Positive to the right, negative to the left. So this is actually negative. See, the length is root 3 over 2, but on the coordinate system, it's negative. And this is really important. So that the coordinates are actually negative root 3 over 2 and 1/2. Okay? And so the question that we're answering here would be like, what is the cosine of 150 degrees? Not 15. That's its own, I don't want to go there. That's its own thing. Okay, so cosine of 150 degrees, and we now have it because we have the coordinates in the unit circle. That's simply negative root 3 over 2. Okay? And you could actually get a lot of them like this. Okay, you can get there's a lot of symmetry, and I think what I'll do is I'll pause here, and I will, in one final video, look at the triangles in terms of all their symmetries. Okay, but here's the goal. The goal from the unit circle is to be able to get the sine and cosine of really all 30, 60, 90, and 45, 45, 90, and their multiples of the sine and cosine. Okay? So we want to be able to figure out not just like sine of 45 degrees, which if you know your 45, 45, 90 triangle, depends on how you look at it. I think it's commonly written as root 2 over 2. But we can also get then like the sine of, say, 135 degrees. Okay? And so we're going to look at all these different kind of combinations in the next video.